Hello, my name is Jake, and today I'm going to be running you through my final project for ENME 435 remote sensing, in which I constructed, programmed, and implemented a LiDAR sensor that I use to map an outdoor on-campus target.
The target that I chose to map for this semester is the Jim Henson and Kermit the Frog statue outside of Stamp. This is a statue that I pass a lot on the way to class and throughout my day, and I always enjoy looking at it, and I think it really represents the historical significance of the university as well by depicting one of its most famous alumni. Here we get a 360 view of the target. The pertinent features here are the statue of Jim Henson and Kermit, as well as the bench they are sitting on. Capturing the details of the characters as well as the poses they are sitting in proved to be a great challenge during this project. This is my configuration for my LiDAR sensor. We have a Raspberry Pi that controls this 8 megapixel camera module right here, as well as an Arduino which powers a line laser that we were provided, shown right here. The laser was fixed using Gorilla Glue to this 3D printed LiDAR mount, which is fixed to this larger tripod, shown here, that I got off Amazon. The camera is fixed using screws that I custom ordered from Amazon as well, and zip ties were used to tie down all other components. This LiDAR sensor is an active sensor in that the laser acts as the transmitter and the camera acts as the receiver to determine the shape and distance of the target of interest. To fix my laser properly in place in relation to my Raspberry Pi camera, I used the laser alignment image script, as we see here, to put the laser in a perfect horizontal with the camera. Unfortunately, during the glue drying process, the laser once again became misaligned, and there was nothing I could do about this, which led to some problems that had to be accounted for in data processing, which we will touch on later. The next thing I had to do was calibrate my LiDAR sensor to be able to accurately measure distance when deployed in the field. I did this by projecting the laser onto a blank wall and taking a series of images using the laser alignment script that we were provided. I would input the distance from the wall that I measured physically using a tape measure. I then used the laser alignment Python script that we were provided to plot the distance from the wall of the LiDAR sensor as a function of the number of pixels from the center that the camera perceived the laser to be. I then adjusted the parameter values that were coded into the script to find the best fit line to encompass these points, and we can see here that I ended up finding a pretty good fit with the parameters that I used. And with this, my sensor was finally ready to be deployed in the field to measure my target. I used my Raspberry Pi setup to take multiple scans from 4 different sides of the target. We see here my setup from behind the target. There's that construction light there that we can see projected a little bit on the front, but we had ways to get around that. Here's another angle of me recording. I had a partner come and help me by holding up a towel to block out that construction light while recording. And here are some of the images that we ended up getting. We see pretty clear laser shown on Jim Henson's head. Due to laser misalignment, we see that it comes in a bit of a diagonal, but you'll see in the future video how I accounted for that. To generate the point cloud for my project, I used the data generation script that we were provided, modified to match current Python. I did this using HSV values for each of the scans that I did using the color picker shown here. We see that due to misalignment of my laser during the construction process, my scan was off a little bit, showing a bit of a diagonal here, and some post-processing was required. So what I did was make this script that calculated the centroid of the filtered values, and then rotated the y values about this centroid in order to straighten it out a little bit. And we see the result of this here with the red overlaid with the white original. And we see that we were successfully able to move those points back in place. Then I loaded all 4 scans into Cloud Compare and moved them around to match with each other. And here's the completed scan of Kermit and Jim Henson. And we can see them sitting on the bench here. We have Henson on the right here, and then Kermit on the left. So all in all, the scan came out pretty well. With the point cloud completed, the only thing left to do was create a mesh. And I did that by computing the normals as seen here. And then using the plugin Poisson Recon to convert the point cloud into a mesh. We can see it doesn't come out too clean. You obviously have this sheet here that could be shaved away. The bench comes out in somewhat decent quality. We can see some features pop out. We can very clearly see this is supposed to be Jim Henson sitting over here, and we see Kermit's head, but they don't exactly come out as intended. We can see his legs down here. So although it's a bit of a mess, we can still see some of the pertinent features of the target. And that concludes my semester project for ENME 435. Thank you so much for watching, and I look forward to applying the skills that I learned throughout this semester in my future endeavors.